Okay, here we are in MATLAB, and as always, I've got the command history all loaded up full of things I can recall for later. Now, the good news is MATLAB is really good at calculating eigenvalues, and the better news is it's not very hard. So let's start. First thing I'm going to do is I'm going to pull up that matrix, that 2 by 2 I used on the board before. And the command in MATLAB that you use to calculate eigenvalues is EIG. And let's just use the simplest instance of it. There it is. Now those are the two eigenvalues I found earlier. Now in this case, the eigenvalues happen to be in order from smallest to largest, but I don't think that's always the case. If you want to sort them from smallest to largest or largest to smallest, either one, you'll have to use the sort command to do that. Can you calculate eigenvectors? Sure, you can do that too. The way to do it is to have the eigenvalues and the eigenvectors sent to a result rather than just have them echo to the screen. So let's try this. I'll say x for eigenvectors and val for eigenvalues, EIG, A. And I'm going to suppress the echo here. So there it is. I've got these two entities up here. What are they? There's val. Okay, and the eigenvalues appear as a matrix. There's the first one, and there's the second one we calculated before. And let's go ahead and say vec. There's the two eigenvectors. Now on the board I mentioned there's a couple different ways to normalize eigenvectors. Because we have one more unknown than we have equation, we have to pick one value for one of the elements of the eigenvector and use that to calculate the others. The easiest way to do it is just simply select one to be 1 and then calculate the others. MATLAB uses a different method of doing that. If you like, you can take the largest element in your eigenvector, set that equal to 1 by dividing the entire eigenvector by that if you like. So I could say vector all the rows, first column, divided by first row, first column. And now I've normalized that first eigenvector. So you can do that if you want. These are proportional. It doesn't change the proportions. Okay, let's clear the command window. Let's try something else. Let's pull up A, and let's make a B as well. I think I did this before. There, 1, 2, 3, 4. And let's treat this as a generalized eigenvalue problem. So I'm going to do the same thing. I'm going to type in EIG, and now I'm going to give it both A and B. Now it's solving the problem AX equals lambda BX. That's the generalized eigenvalue problem. And there's the answer. Well, could I convert that into a normalized problem? You bet. Let's do this. Let's type in B times A, just like I did on the board. And there's the same two eigenvalues. Now notice they pop up in different order. That doesn't change the fact that you've got the same two eigenvalues. It just happened to extract them in different order. And this is what I mean. If you want to go smallest to largest, you're going to have to sort yourself. What would this look like for larger matrices? Well, how do I make a larger matrix in MATLAB without writing code? There's this cool thing called a magic matrix. A magic matrix of order n is an n by n matrix, and it's made from the integers 1 through n squared. It has equal row and column sums. So I could say something like magic 5, and there it is. And I can make a picture of it if I want. Oops, spell it right. Bring that there. Now you can see it's got a pattern seems to be emerging. When you use odd numbers, whoops, there we go. Let's make it 51, make it really big. You get this cool diagonal pattern. That's a magic matrix. When you use even numbers, you get a different pattern. So let's say A equals magic 5. And B equals, let's make these random numbers. If I say RAND of 5 and hit return, I get a 5 by 5 matrix of random numbers. Okay, well, can I do EIG-AB? Sure. There they are. Now, these are complex. That's not at all unusual. Eigenvalues are very often complex, and the real and the imaginary parts of the complex eigenvalues oftentimes have very specific physical meanings. But in general, you shouldn't expect your eigenvalues to be real. So what would the eigenvectors look like? Let's do this exact same thing as we did before. Let's just make it generalized, though, and see what the eigenvalues and the eigenvectors look like. So there we are. Let's look at the eigenvalues first. It'll be in matrix form, but it should still be those numbers. All right, there they are. Are those the same numbers? Yeah, sure looks like it. Different order, but that's them. What would the eigenvectors look like? Well, there they are. 5 by 5 matrix of eigenvectors, also complex. Just as your eigenvalues are often complex, so can your eigenvectors also be complex. So you can play around with this on your own, but the bottom line is that calculating eigenvalues and eigenvectors in MATLAB is really pretty straightforward. I hope this helps, and we'll talk to you next time.